Saturn's rings give it the majesty befitting a planet named after the Titan king. Its rings, which are nearly entirely made of ice and stretch millions of kilometers in width, are its most captivating feature. They have mesmerized humanity since Galileo observed them with a telescope in 1610. But what would Earth look like if it were capped with rings? Because rings are most stable around a planet's equator, the appearance of the rings varies with latitude. For example, at the equator in Quito, Ecuador, the rings would be visible from the inner edge on, like a thin line rising straight up from the horizon. While in comparison, the rings may appear like a hump on the horizon around the Arctic Circle. Earth's projected rings would be distinct from Saturn's in one important way. They would be devoid of ice. Because Earth is significantly closer to the Sun than Saturn, radiation from our star would cause any ice in Earth's rings to melt. Even if Earth's rings were composed of rock, it doesn't guarantee they wouldn't reflect any light. The Moon's rock is mostly gray, and it barely reflects around 12% of the light that falls on it. The full moon, on the other hand, looks incredibly brilliant due to a substantial amount of light falling on it, and because of its close proximity to us. But how brilliant would Earth's rings shine? Approximately 1,300 watts of sunlight per square meter strikes the top of Earth's atmosphere. If rings reflect even 10% of that, each square meter would reflect the same amount of light as a 130-watt light bulb. The rings would probably reflect enough sunlight that Earth would never fully plunge into darkness, but remain in a gentle twilight even in the depth of night. During the day, the rings could potentially cause light levels on Earth to skyrocket. Earth's shadow may even fall on the rings, depending on the time of day, season, and latitude of the spectator. Earth's shadow would appear oval-shaped on its rings and move as time passes. Earth's shadow would appear oval-shaped rather than circular for the same reason that your shadow appears stretched out in comparison to you. The Sun would be on the same plane as the rings during the equinoxes. Near these periods, the planet's shadow would appear to spread over the rings to their maximum extent, plunging substantial areas of the rings into darkness at Earth's middle latitudes. The rings would appear to divide the Sun at the equator, throwing a stunning shadow over half the Earth. They would cast shadows on the southern hemisphere during the summer in the northern hemisphere, and the winter in the southern hemisphere, and vice versa. This might imply that winters in both hemispheres will be colder and harsher than on Earth. At the same time, ring shine may increase the overall amount of light that Earth gets, making predictions of its climactic implications difficult to define. How probable are rings to exist on rocky worlds? Previous research discovered that Mars' moon Phobos may have originally existed as rings around the red planet. Phobos will most certainly be torn into a ring again when it comes closer to Mars over the course of millions of years. It's possible that Earth had a ring before. Our planet was created roughly 4.5 billion years ago, and earlier study indicates that the Moon emerged not long after. The most common hypothesis for the Moon's formation is that it was formed by the collision of two protoplanets, or embryonic worlds. One of them was the infant Earth, while the other was Theia, a Mars-sized rock named after the Moon's mother in Greek mythology. The collision would have created a ring of debris surrounding Earth, which later merged to form the Moon. In summary, while the idea of a ringed Earth may appear to be a fiction, it may have once, for a brief point in time, been genuine.